I'm Can Erdoğan.
I'm Ateş Türkoğlu.
Today we will present to you ecosystem restoration promoting biodiversity in Brookline Bozalan quarry. Let's start if you wish.
Now I'm going to talk about our project. It was not only renaturalized limestone-dominated mining sites in Bozalan of the region of Çanakkale with sustainable environmental policies, but also set an example at national and international level for cost mining. In this process, ecological restoration, reducing carbon footprints, environmental sustainability, awareness and education. Speaking of education, in our school there is a different grades from kindergarten to high school, which allows us to interact with the different students with different ages. And finally, innovative methods developments were our main headlines.
Now let's move on to our targets: restoring natural ecosystem, coordinating the seed balls, and to present our knowledge to students, parents, and people of Bozalan through various posters, presentations, and trainings, and to raise awareness on this issue.
To briefly talk about our project, firstly, we opened slowing cavities at certain intervals and diameters in the quarry. After that, we planted the seedlings we selected in accordance with the flora of the region of the mine, and then we planted the seed balls we made in these cavities with the fertile soils. After this process, today we are going to complete the photosynthesis rate, and with the carbon sequestration obtained with the energy spent, and evaluated the process, positive impact in our process, and thus we are reaching our goal of becoming a national and international level for post-mining works.
So let's talk about our ce3e0b5a factory. It's located in Mahmudiye, Izmir, in Çanakkale, and it was formed in 1996, and it was the merger of two different factories actually, and it produces 5.5 million tons of cement and 4.5 million tons of clinker annually, and it covers approximately 10% of the Turkey's need right now, and also 30% of its energy comes from the waste heat recovery facility, and Turkey's first and only waste tire shredding facility is also located in this factory. And you can see some pictures of the factory here.
Our fieldwork took place in Bozalan mine quarry in Çanakkale, and we traveled from Izmir to Çanakkale for this presentation, and also we had visited here before for our fieldwork.
So what is a seed ball and how is it made? Seed balls are basically handmade products which is made to facilitate and protect the direct planting of the seed into the nature, and it's so easy to make. The proportions are 5 clay, 3 compost, and 1 soil and water. So how to prepare? It starts with mixing clay, compost, soil in a large basin, and you add slowly water to this mixture to make a dough. After you mix them and you have your dough, you take some parts and make them walnut-sized balls in your hands, and you put 3 or 2 seeds in each bowl, and after that you let them leave. You leave them to dry in a shaded room, room, and 1 or 2 days. Here you can see me making seed balls too. That's me making the dough.
It was quite easy process, by the way. Like we also have fun, and we have some educational time at this point.
And here is some suitable species for seed balls. For example, thyme, black head lavender, poppy, bird millet, white clover, white mallow, wild oats, and more.
So moving on with the material list for the mining plan. So as my friend mentioned, there are some main materials we need to have to make the seed ball. So we first started by gathering them. So then we clay soil, compost, local soil, and water. And then we determined 4 types of seeds that we wanted to work for that were suitable for the occasion. So poppy seeds, thyme seeds, blackhead lavender seeds, and wild mallow. And we also determined 2 types of saplings, red pine and laurel sapling, to use on the mining site. And moving on with our method, as my friend showed how we made it, we started by making the seed balls, and after we did the seed balls as a group, not only ourselves but including students from our project middle schoolers and high schoolers. And after we were done making the seed balls, we let them to dry for a day. Later, we started by making our prototype in the entrance of our school. We brought limestones and we dug holes in them and we placed the seed balls, and we regularly checked rows, which we will show you in the upcoming slides. And we also placed informative posters around the prototype to raise awareness and involve students as well. Yes, thank you. And we did a presentation at İzmir Wildlife Park, including students, a very interactive presentation where we involved students through asking questions and answering questions. And at the end of the presentation, we made a seed ball making workshop with volunteering students, where they were brought up to the stage and they mixed the ingredients and they made seed balls, so they learned it firsthand from us. If there's any other of my friends who'd like to share their experiences.
For me, it was such a valuable experience, and I really enjoyed teaching and sharing our work with students.
When it comes to seed ball placement, when and where they're going to be placed is quite important. For the time, October, November, and the start of spring are the most ideal months, and for the area, places that are slightly rocky with bare soil will be selected, and in those areas, seed balls will be placed in holes dug in steep slopes next to pathways. It's also important to mention that seed choice can affect the area. For example, plants like lavender and thyme need more shady areas compared to other plants. At the bottom, you can see a short infographic about seed ball placement. First, you need to find a suitable area to dig holes and dig them. Then prepare the seed balls as I mentioned before. And then after that, all that's left is to actually place them and water them periodically. Now, for the reason behind us digging holes in limestone and then placing it is that it comes with a couple of benefits. Firstly, it prevents harsh winds to blow away the seeds and maintains a certain amount of temperature and moisture, which is necessary for the seed's adherence. Also, thanks to the water and organic matter that accumulates inside of these holes, it makes some sort of microclimate, which helps the seed's germination. Another thing is that it protects it from harsh sunlight, birds, and other animals that can harm the plants. Finally, it protects it from erosion. There are some things to look out for while placing seed balls, which if you are going to plant them next to saplings, which is what we recommend, the hole depth should be 1 to 1.5 meters deep and 10 to 15 centimeters wide. If it's any wider or deeper, it can cause too much water to rot the plants. Another thing is the seed ball mixture. It's quite crucial for the keeping it moist and protecting the seeds. One of the main key things is the seed selection. The main thing is to select vegetation that is native to the area and that are resistant to drought and small amounts of soil. Also, as I said before, the location and seeds are important as well. Here you can see a 4-day sample seed implementation plan. On day 1, you're going to be preparing the materials and area. Here you'll be finding places to dig the holes and dig them. On day 2, you'll actually be making the seed balls, making sure that the correct consistency and every ball has 2 to 3 different types of seeds. After you're done making them, you need to leave them out to dry in shade for at least 1 day. Day 3, after they're done drying, you're actually going to be looking at the weather forecast to find a good day to actually go on with the plantation. And on day 4, the final day, which should ideally be rainy, you're going to be scattering the seed balls inside of the holes, which should be 1 to 2 meters apart from each other.
In an ecosystem, nature process takes place over time, eventually resulting in a stable, self-sustaining plant community, which is climax vegetation. And why is this so important to our project and aim? Because it prevents soil erosion, it enhances biodiversity, it contributes to climate change mitigation through carbon separation, and also it restores ecosystem services such as clean air, water cycling, and dust retention. Our project focused on helping nature disasters such as dust mining areas, which is like so what are we doing? We give importance to, first of all, plant selection, of course. After that, we use some techniques which is, as my friends mentioned, using seed balls and enchant the soil with fertile substrates, and then we monitor photosynthesis and carbon storage. After that, we use these methods help speed up the natural plant succession, allowing to ecosystem reach its climax vegetation, which is more quickly and effectively. And let's go with another question. Can we really reduce carbon footprint with plants? Yes, we can. Because of the technique that plants are using, which is like they absorb carbon dioxide to their own biomass and store them, and like they may lower the atmosphere's carbon dioxide level. And like if we can measure how much plants absorb carbon dioxide, we can also measure that how much we save save carbon footprint, which is we are going to use in our project.
And for our measurement process, we are working on two separate places. On the first area, we have red pine and laurel saplings alongside seed balls that we have planted this year. And on the second area, we have red pine trees that were planted 7 years prior. In the first area, we are going to be measuring the photosynthesis efficiency, and in the second one, we are going to be calculating the carbon capture capacity of these trees. Using those two data, at the end, we're going to see if we were to cover the entire quarry with trees, how much would we actually reduce the carbon footprint by, how many tons of carbon dioxide would we have captured.
So now I'm going to explain how to measure photosynthesis, and my friend is going to show it on the device. So first, we select 3 or 4 leaves in a medium-sized nature plant, and after we choose the leaves, we attach clamps, as you can see there, on the leaves, and that's for keeping a specific area in darkness for 30 minutes. After 30 minutes, we press the button on the device, and it will open the light emitting head, and we will attach the head on the clamp. And after that process, we open the clamp shutter to expose the leaf to light for a short period, and after that we will have our results, and with 4 results we are going to take the average of them, and we are going to get the result.
For our carbon capacity calculations that we are using according to there are a couple of steps that we take during this calculation. First, we find the basal area of the trees using their diameter at breast height. Then we find their volume, which then we use to find the dry biomass, which is the part that actually has the carbon inside. Then we use the carbon fraction, which is set to 0.47 by the IPCC, to find the carbon stock. And then multiplying it by the number of trees, we can find the total amount of carbon, which then we use that to find the carbon dioxide equivalent of how much CO2 we captured, which turns out to be, for 12 trees, 0.7 tons. And then we multiplied it by the carbon pricing, which is 54 euros. And this showed us that with just 12 trees, we got even this much. So if, it gave us hope for how much we would actually contribute.
Here you can see the list of our materials. We used 2 different seedlings with 4 different seeds. In total, it cost $130.
We set up a mini version of our fieldwork at the school entrance and worked with the students during break times, which gave us a great opportunity to explain them about our project. And from kindergarten to high school students, around 1,400 in total visited our terrain model, and it was a joy to see their curiosity and engagement at every stage. We were happy to see seed ball germs on our terrain model. This shows that our method can also work at the Bozalan mine site.